Well, hi everyone. We have practice test 12 here to go over. Number one says, for one, use f of x equals x cubed plus 4x squared minus x minus 2. We're going to find these two values here. So first, let's find f of negative 3. That means take the x's out of f of x and put negative 3 in their place. And okay, so any place there was an x, I used in parentheses, I put a negative 3. Now let's do the evaluation. Negative 3 to the third power is negative 27. Negative 3 to the second power is positive 9. Minus a negative 3 is plus 3, and then minus 2. So let's go negative 27 plus 36 plus 3 minus 2. That's 9. 9 plus 3 is 12. 12 minus 2 is 10. Now this next one, we're going to go negative f of 3z. I'm just rewriting it there. I don't want to do that. I'm going to put the negative and then parentheses. And then put 3z in place of every x here, cubed, and then 4, and put 3z in place of x squared, minus, and then 3z in place of the x there, and then minus the 2. I still have this negative out here. I'll deal with that at the end. Negative 3 to the third is 27z to the third, plus 4, and this is 9z squared. Then I got the minus 3z, and then the minus 2. So that is okay. So I'm picking this up here. Let me finish. Okay. I'm going to put an equals right here, then an equals here. I'm still going to keep this, and then figure out that's 27z to the third here still. 4 times 9, that is 36. That's z squared. Those are not like terms. Minus 3z minus 2. So I'm going to go negative. I'm going to distribute this negative across here. So negative 27z to the third minus 36z squared plus 3z plus 2. The degree of f of x is 3. The lead coefficient is 1. The coefficient of that. All right. We're going to use the graph to answer this question here. Describe the end behavior here. Now, as x goes to negative infinity, f of x is also going down at negative infinity. As x means as we go right, f of x, that is going up, so that's positive infinity. Does this function represent an odd degree or an even degree function? If one side's down and one side's up, it doesn't matter which side, left or right, is up. If they're opposite, then that is an odd degree function. How many real zeros does this have? You just count 1, 2, 3 places that it crosses the x-axis. Not asking for what they are. We'll do that later in this test, but just asking that. All right. Next one. Same kind of question. Describe the end behavior. As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches positive infinity. Does this function represent an odd degree or an even degree function? And I would go even degree here. And how many real zeros does this function have? 1, 2, 3, 4. All right, number 4. same kind of problem. Describe the end behavior. As x approaches negative infinity, f of x is approaching positive infinity. That's on the left. On the right, it's going way down. So that would be negative infinity. Does this function represent an odd or even degree? Both sides are, well, they're not going the same direction. One's up and one's down. This is an odd degree function. And how many real zeros? I see one here. I see one here. I see two real zeros here. All right. This one, describe the end behavior. As x approaches negative infinity, f of x approaches negative infinity. As x approaches positive infinity, f of x is approaching negative infinity. Both sides are down. The far right left is down, far right is down. Odd or even, both sides are down, that is even. How many real zeros does this function have? 1, 2, 3. I count 3 real zeros there. Now on this one, I've got two, on the practice test I have 2 questions like these. I am going to use, for one of them, I'm going to use a graphing calculator. All right? And then the other one I'm going to use Desmos. So f of x equals x cubed. So here's x to the third minus 3x and plus, oh, okay, I did it again. X cubed. Now I got to get it down so I'm not typing everything up in the exponent. Minus 3x plus 1. I'm going to graph that. And if I have the standard, and this is a good side of it, if you ever get to where you can't see it, if you zoom and 6, and you just want to see the standard window, negative 10 to 10 on the x, negative 10 to positive 10 on the y, that's what it looks like. All right, so we're going to list the zeros, which is second calc, or second trace. I'm going to go down here to 0. I'm going to get this far left one first. So left bound, I'm below, enter. Come up here, right bound, I'm above, hit enter. I'm getting negative, I'm going to go 3 decimal places, negative 1.879 on that one. Second, oops, okay, let me clear that. Second calc, get a second 0, counting 3 of them here. Okay, I'm above, hit enter. I'm below, I'll hit enter. I'm going to get 0.347. Coordinates, whoop, I got one more 0. Second calc, I go to 0, hit enter, hit enter. I'm below and left. Now right bound, hit enter, hit guess, hit enter. 1.532. Okay, so that's how you use the calculator to get those. I have a maximum right here. I want to find the coordinates of, so second, and then the trace, which gives me the calc menu. I want to get that max. So I hit enter. Now I got to be left of that peak. Enter. Now I got to be right of that peak. Enter. Guess. Hit enter. Now I'm going to use this as -1. So that is -1.3. You see some rounding there. And when you have a bunch of zeros like that, it is most likely rounding for the exact. So, all right. Now let's get the minimum here. Second trace. I want the minimum, number 3 here. I'm going to go, I'm left of that dip. Now let's go down, complete the dip and get up a little bit, and hit right of the dip and hit enter. And it's rounding again, but I think that's 1, -1. Now the end behavior here, as x approaches negative infinity, f of x is approaching negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Okay, the intervals, and this is these next two questions are maybe the trickiest of them. All right, give the intervals on x for which f of x is increasing. Okay. So from the far left until I get to here, negative infinity until, and if you'll recall, that point is negative 1, 3. So it gets up to 3 here, but negative 1 is the x value, so it's the intervals on x that we put there. It is increasing. Now, also from this point here, this 1, negative 1, it gets down to negative 1, but 1 is where the x value, where it starts increasing, and then it'll continue to increase there. Oops. I should put that there, not where I put it. Now decreasing from negative 1, 3 down to 1, negative 1. But I put the x value, negative 1 to positive 1. Negative 1 to positive 1, it is increasing. All right, we're going to make a decent graph here. I'm going to put the 0, negative 1.879. That's real close to negative 2 here. 0.347. Put there 1.532, about 1.5 there. Negative 1, 1, 2, 3 is a high point. I know it hits 0, 1. I know that's the y-intercept because of this 1 here. With x is 0, you saw the 1. And then 1, negative 1. It goes down here. It kind of starts down here, hits that peak, comes through this point, curves down there, and then goes up pretty quickly there. All right, domain, all real numbers, always on polynomials. The range, now in this case we're going from negative infinity to infinity. So we have the range is the same there. All right. This next one, I have typed that in already. So I'm going to list the zeros. I got that typed into Desmos. Where is that mouse? There it is. Okay, negative 0.618. Zero goes through the origin. This one does. I might just do this here. That's 1, and that's 1.618. Let's do 1 and then 1.618. Coordinates of the relative maximum. That, negative 0.366 and 0.25 and 1.366, 0.25. Negative 0.366. 0.25 was 1 max, relative max, and 1.366, 0.25 was the other max. Now the minimum here, got a bunch of, that is 0.5, negative 0.313. 0.5, negative 0.313. Okay, you see on this one where both ends are going down. So this is negative infinity on the left, negative infinity on the right. Now increasing. It increases from the left, from negative infinity until I get to this high point, which is, those are the coordinates at that point, negative 0.366, 0.25. So that is increasing, and that is negative infinity to 0.25. I see another increasing from here to here. And it's the x's. 1 to 1 point, no. So this goes with this one. These are getting close together. But 1 to 1.366. Okay, I miswrote on this one. Wow. Okay, I've been trying to get you not to do this y, and I just did it. It goes up to 0.25, but the x-coordinate that gives you that is negative 0.366. So, okay, negative 0.366. We're doing the intervals on x, so don't forget that like I just did. All right, decreasing. From this point, negative 0.366, 0.25, down here to, this is, oops, let me get these zeros off here. Okay, all right, this, from here to here, it's decreasing. I'm not sure if that's showing up. It's not. Okay, from here to here, it's decreasing. Use the negative 0.366 and the 0.5. Use the x-coordinates. Point 0.366 to 0.5. Sometimes I write the 0, sometimes I don't. And then on this right side, you go from here to 1.366 to infinity. Now I know it's going down, but we're doing the x's, remember, so it goes down to the right forever. 1.366 to infinity. All right, let's use all this. Let's put our zeros down. Negative 0.618 right around here. 0 is right around here. 1 is right here. 1.618 right around here. This is kind of tight here. I got 0.366, 0.25 is right around here. 1.366, 0.25 is right around here. And 0.5, negative 0.313. All right. So we come up, come down, come up, come down. All right. All right. Domain. All real numbers. Range. Negative infinity. Low to high. And the high points are 0.25. Okay. Now it's the factoring time. You will have this on your test. And this is the pattern for this one. This is x cubed plus 5 cubed. So we take the x plus 5, and we do the x squared plus x times, not plus there, look at your pattern, minus there, minus x times 5 plus 5 squared. So that's x squared minus 5x plus 25. Okay, 27 to the third power is 3 to the third power. So that's 3 to the third power, y to the third power. So I'm going to write this as 3y to the third power minus 1 to the third power. So this is a subtraction one. So, oh my goodness. Okay. Let's just say a minus b. All right. I'll make sure that's okay on the test. So 3y minus 1. And then I'm going to write this, 3y squared plus 3y times 1 plus 1 squared. Now 3 squared is 9. So y squared is y squared. 3y times 1 is 3y. 1 squared is 1. Now, remember our grouping. Let's see. These all have y's. These all have x squared. So I think it's in a pretty good order right now. 6, 4, 4. 2 goes into all of those also. 2 goes into 6, 2 goes into 4, and 2 goes into 4. And y goes on. So there's the greatest common factor. If I take 2y out of 6ay, I get 3a. If I take the 2y out of this. If I take 2y out of this, I get minus 2b. If I take 2y out of this, I get plus 2. Now for these, I'm going to go negative. If negative's in front, I'm going to go negative. There's no numbers here. I'm going to go negative x squared. And if I take negative x squared out of this, I'm taking the negative out and the x squared out, so I have 3a. If I take negative x squared out of here, I need negative 2 and then b here. And if I take the negative out of here and the x squared out, I got plus 2 here. Now, when they have that in common, remember we put the, I'll just write that out again, the first terms times the common term. No, actually, that's not quite accurate. Common expression. Okay. Now, so let me put 2y minus x squared here. And let me put 3a minus 2b plus 2 here. And we've got it factored. And you'll be happy to know that that doesn't factor and that doesn't factor. So we'll just quit there. Okay, now this is in order, so when you have one like this and it's in order, you keep it in order. X cubed will go into all three of these. If I take x cubed out of this, I still have x squared. If I take x cubed out of this, I still have the 2 and the x. If I take x cubed out of x cubed, I have to write this 1 here. Now, 8x squared plus 16x plus 8. 8 is a common factor. 8 goes into 16, it goes into itself too. So I have x squared. If I take the 8 out, if I take the 8 out of this, I still have a 2x, and take out of that, I still got the 1. So now, I've got x cubed plus 8, and here I got x squared plus 2x plus 1. Okay, this is a good answer, and this will get you good points, but I need you, this is a difference of cubes. X cubed plus 8 is equal to x cubed plus 2 cubed. And if I follow this pattern here, I got x plus 2 times x squared plus 2x plus 2 squared, which is 4. I didn't do the writing above like I usually do. Now, x squared plus 2x plus 1. I want you to think about this. I need two numbers that multiply to 1 and add to 2. And that's 1 times 1 and 1 plus 1, right? So this is equal to x plus 1 times x plus 1. Okay, so we had this. We're breaking this down to x plus 2 times x squared plus 2x plus 4. And we're breaking this down to x plus 1 times x plus 1, or x plus 1 squared. All right, there we go.